All right, guys, let's take a look at 12.6 here. So we're going to be finding the surface area and volume of spheres. So you should make a place in your notes for spheres, give you a couple formulas for surface area, volume, and then also hemispheres. We'll talk about that a little bit too. Okay, so surface area spheres, volume of spheres. Okay, in a sphere, I think you know what a sphere is, like a ball. A great circle, if you take a cross section of it, you always get a circle. A great circle is a cross section that goes through the center of the sphere. And so the diameter of a great circle is the same as the diameter of the sphere, and that's something you should know. The poles on a sphere, I mean, think of North Pole, South Pole on the Earth, kind of same idea. And a hemisphere is just half a sphere, okay? So surface area formula, make sure you get this in your notes. 4 pi r squared. So all you need to know is the radius, and then you can calculate the surface area of a sphere. So make sure you get that in your notes. Okay, so find the surface area of the sphere round to the nearest tenth. Your r is 4.5, so you're going to replace that r with 4.5, put it in the calculator, 254.5. No big deal, okay? Why don't we try one? Okay, so surface area here is 4 pi r squared, which in this case is going to be 4 pi times 6.25 squared. 4 times pi times 6.25 squared. I get 490.87 or 490.9. Looks like D is our answer. As long as you know the radius, this is a pretty straightforward formula. Okay, how about hemisphere? Okay, this is a little tricky to think of because certainly on the outside, it's half of whatever a sphere was. So if we had 4 pi r squared, half of that would be 2 pi r squared. But you've also got that cross-sectional circle at the bottom that you have to take care of. Well, that cross-section is going to be, pi r squared, just a circle. So if I go plus pi r squared, that would be 3 pi r squared. So when they ask you to find the surface area of a hemisphere, add that to your notes, 3 pi r squared, because they're going to look at it more this way. You can just simplify it and make your life a little bit easier. So our radius is 3.7. We can go 3 times pi times 3.7 squared. Okay, I get 129 or so. Okay. Let's see what they get. They're going to do it in a similar fashion, but so half of 4 pi r squared, there's the 2 pi r squared we got, plus the pi r squared for the cross section at the bottom. Okay, so they're going to put all of that stuff in there. They're going to get the same 129 that we got, but doing it a little more complicated. So 3 pi r squared will get you the surface area of a hemisphere. Okay, so find the surface area of a sphere if the circumference of the great circle is 10 pi feet. Again, if we're looking at a great circle, the diameter of a great circle and the diameter of the sphere are the same. So remember how to find circumference, pi times diameter. So we can find the diameter here. So pi times diameter, 10 pi equals pi d. So diameter is 10, which means our radius is 5. Well, now that I know the radius, find the surface area. Our formula is 4 pi r squared. We're going to put a 5 in, and there we go. Okay. This time, find the surface area of a sphere if the area of the great circle is 220. Okay, so how do we find the area of a circle? Well, that was pi r squared. So now I have to set pi r squared equal to 220. That will help me find r. Then I can put that back into the surface area formula for our sphere. So you would divide by pi and then take the square root, and you should get about 8.4. Well, now we can go 4 pi r squared with that 8.4 in mind and get a solution. Okay? And we'll work a couple out together here. So find the surface area of the hemisphere, first of all. Okay, so we said the surface area of a hemisphere was 3 pi r squared. So that's 3 pi times 4.2 squared. Okay, that's how I would work that one out. So 3 times pi times 4.2 squared. I get 166.25 or 0.3, so it looks like B. Okay. What about this? Find the surface area of a sphere if the circumference of the great circle is 8. Okay. So I knew that circumference was pi times diameter. Circumference, they told me, was 8 pi, so that's going to be pi times diameter. So the diameter is 8. And if the diameter is 8, then the radius is, of course, 4. And our surface area formula for a sphere is 4 pi r squared. We said our radius is going to be 4. So 4 times pi times 4 squared, we get 201.06 or 0.1. Okay? So a little bit of work to find that diameter and the radius, and then I can plug it in. Okay? One more. So now they tell me the area of the great circle is 160, and I still want to find the surface area, so I got to find the radius. Okay? I know that the area of a circle is pi r squared. They give me the area. Okay, so now I want to get r by itself, so I'm going to divide by pi. 160 divided by pi, that's like 50.9. And then I have to undo an r squared, so I'm going to take the square root. So the square root of that answer is about 7.1. Okay, now keeping that in mind, our surface area again was 4 pi r squared. We're going to use that 7.1 this time. So 4 times pi times so 4 times, oops, hitting the wrong buttons here, you guys, apologize. Pi times that 7.1 squared, you get like 633-ish, 640, if I allowed the decimal to go out farther. So, let me try it one more time. So 160 divided by pi, and then the square root of that answer. So I'm going to use that long decimal here and see what I get. 4 times pi times that number squared. Now I get 640 exactly if I use the long decimal. So, you know, if you're trying to match answers to the back of the book, try to use the entire decimal instead of just 7.1. Okay? All right, so the volume, make sure that you add this to your notes too. 4/3 pi r cubed is how you find the volume of a sphere. So, find the volume of a sphere with a great circle circumference of 30 pi. Again, circumference is pi times diameter, so that means the diameter must be 30, which means the radius is half of that, or 15. So then I can plug that 15 into the 4/3 pi r cubed. So 4/3 pi times 15 cubed gives me that big number there. Okay? So this time, find the volume of a hemisphere. Well, the volume of a hemisphere is just half that of the volume of a sphere. So instead of 4/3 pi r cubed, I could do 2/3 pi r cubed. And the radius there is going to be 3. So instead of that, we'll do 2/3 pi r cubed. Radius is 3, so about 56.5. Okay? So let's try one here. Find the volume of a sphere to the nearest tenth. So volume 4/3 pi r cubed. Okay? They give me everything I need this time, so I'm going to just plug it in. 4/3 times pi times 8 cubed, I get 2144.7. Okay, if you round. Not too bad. Know the formula, plug in what you got. Okay, now I'll find the volume of the hemisphere. We said the volume of a hemisphere would be 2/3 pi r cubed. Okay, our diameter is 80, so our radius is going to be 40. So we're going to go 2/3 times pi times 40 cubed. And let's see what we get here. So 2/3 times pi times 40 cubed, 134,041.3. Pretty big number. 40 cubed is a big number. Okay? All right, the stone spheres of Costa Rica were made by forming granodiorite boulders, okay, into spheres. One of the stone spheres has a volume given 36,000 pi. What is the diameter? So we're going to use that to find radius and then double it. Okay, so our formula is 4/3 pi r cubed. I can replace volume now with that 36,000 pi. First thing I would do is divide by pi, so you can lose those pi's. Now I'm going to get r by itself, so I'm going to multiply by the reciprocal, 3/4, and you get 27,000. How do I undo cubing something? I have to take the cubed root, okay? If you go into your math menu, there's a cubed root option. Otherwise, raise it to the 1/3 power, okay? So the cubed root of 27,000, they're just showing you how to raise it to the 1/3 power in the calculator. If you go into math, though, you do have a cubed root option. That ends up being 30 for a radius, so the diameter's got to be 60, okay? And I'll work through one with you here. So the jungle gym outside of Jada's school is a perfect hemisphere. It has a volume of 4,000 pi. What is the diameter? So again, a hemisphere has a volume of 2/3 pi r cubed. They've given me the volume, so we're going to say 4,000 pi equals 2/3 pi r cubed. Both the left and the right side have a pi involved, so I'm going to get rid of that. So I'm going to go 4,000 equals 2/3 r cubed, okay? And so then to get rid of the 2/3, I'm going to multiply by the reciprocal, 3/2. Okay, so that gives me 6,000. Okay, and now I need to take the cubed root of that. So I do that, I get about 18.17. And that's the radius. So if I go times 2, I get 36.3 for the diameter, okay? So that's kind of how I would go through and solve a problem like that, you guys. And there's your assignment, page 884, 11 to 37, the odds. Good luck.